Hi everyone, my name is Clovis Mesube. So today we'll look at a little presentation on a assignment I've been working on. We'll see a corporate network, secure corporate network design architecture. We'll see a vulnerability scan of my home network, and we'll also see some advanced network concepts. Starting with a corporate network, secured corporate network infrastructure that I came up with. Looking at it from here, we can see a network diagram that is basically kind of divided into two. On this side, we'll see you can call it external network because it's internet facing, and on this side, we can call it internal network because it's not internet facing. And in between the two, we can find a proxy server that acts like a middleman or a good man in the middle between the internal resources and the external resources facing the internet. Since I did the design like this because since the internet is not secure, it's open to everybody. To be able to avoid bad actors getting into the internal network of the corporation. So here we have a demilitarized zone, which is like internet facing and facing the open internet and the internal uh, servers like application servers and email servers that face the internet that has direct access to the internet have to go through the demilitarized zone. Demilitarized zone also do have a firewall which helps to be able to block malicious traffic from penetrating through the internet into the internal network or even through the demilitarized zone itself. Here we also have routers. Have a router that acts like a device that helps to connect internet devices. It's like a computer device with a central hub that connects network devices to be able to distribute network to multiple devices. Passing through the demilitarized zone. If you get access from the internet through the demilitarized zone, then we have another router that routes traffic, sending traffic to the proxy server back and forth, and to the servers, to the mail server and a DHCP server. Then we'll have a switch that helps to do that network distribution. Even between the mail server and the DHCP server, we still have another firewall that helps to filter the traffic as it goes through. On this other side, we have the internal network, which is not exposed to the public internet. So the servers, this internal network is made up of we have like 5 departments. We have the sales department over here, accounting department, the HR department, the manufacturing department, and then the research and development department. And looking at all these departments, we have multiple clients that are connected to the department. These clients have used devices like the desktops or workstations or mobile devices or even the laptops. Through these client machines, they can be able to get connected to their department through the internal network. But in case they need to get anything from the internet, we have the DHCP, the proxy server that acts like a middleman to be able to mask IP addresses of these internal computers to the internet. So if you make a request from the internal network, the request is going to bounce through the proxy server, and then the proxy server is going to mark the IP address. So it will be the request to go to the internet from the proxy server IP address. And the same way, a request coming from the internet is going to go through the proxy server, and it's only going to get to the internal network through the proxy server IP address. So the proxy server here acts as a middleman, receiving the traffic from internal network masking the IP address sending to the internet and receiving the traffic from the internet, and masking the IP address of the source, and then distributing to the right department or the right client in the internal network. Talking about this department, you see some departments can be interconnected. That's why I design it with in a way that uh, someone from the sales department can still have access to can still have some limited access or control access to accounting department and the other departments too. But we'll look down here, we'll see that there's one department, the research and development, that is totally isolated. It's actually air gapped, meaning it is isolated from the other networks and even from the internet itself. It's not internet connected. That way, because this accounting and development accounting department, the research and development department it's what dealing with proprietary informations like the research and development using sensitive information that cannot be exposed, um, critical work that is being done here. That's why this section of the internet of the architecture is air gapped. We also have client servers and other devices connected to it, but that is in a very separate, isolated network, which can only be accessed through a monitored access. So that is it about this architecture diagram. Now what we're looking at is a vulnerability scan that I did for my internal network, for my virtual network. There in the virtual network we have like 7 servers, but it takes a long time for the scanning to run, so I could not scan those servers one after the other. So what I did was put all those servers together and like form one subnet, and then scan one subnet that is going to scan all the servers. So we'll see that on the next slide. So in my server, in my environment, I actually have a Kali Linux, a Debian, an Ubuntu server, Windows 19, Windows 2010, and Windows 11, and all these networks IP addresses. Put them together, to form this subnet. So what I did was just scan this subnet, and by scanning this subnet, it's going to scan all these IP addresses. On this slide, we'll talk about advanced networks. And here we'll start first with the cloud network. Cloud networks provide network services through the internet without physical connections, without any pre-installed hardware, and it has advantages of being very cost effective, being scalable, being flexible, and we have different kind of cloud network provided. Like we have a public cloud, private cloud, hybrid cloud, or even a community cloud. Public cloud here being like public cloud like AWS and Microsoft Azure that are popular. These are, when you talk of cloud here, would actually mean a huge data center wherein they're running very high capacity servers and networking devices where people can subscribe, just buy a subscription, and then get connected to your network without actually having to pay for any devices, and it is pretty much less expensive and cost effective, as it has a pay per use model, or pay as you go model, as they call it. Um, cloud networking here is pretty much very secure because security is provided by the cloud service providers themselves. They provide the best quality of security, so their customers or their users will trust them and buy the services. Then we also have edge computing. Edge computing is edge. Edge computing works to bring uh, compute services closer to the targeted users. Like I said, it has it uses content-driven network to be able to distribute network traffic or computer services closer to the targeted users, having the advantages of reducing latency. Like say for example, if you live here in the United States and you want to run an application that is targeting users far away in China or Japan, using the like AWS cloud services, which gives you availability zones all over the world. It will be an advantage using edge computing or content-driven network to be able to host some of your applications closer to your targeted users. Like instead of using an availability zone that is over here in the US, which is far away from China, you're going to use an availability zone that is somewhere in Asia or in China itself. So the services can be provided to your targeted users with very limited latency. So edge computing actually enhance network in that way that you don't have to install any devices or install any cables between your network and your targeted and your between your server, your host server, and your targeted device and your targeted users. But you can use edge computing to be able to deliver the services no matter wherever your users, your targeted audience are. We also have virtual machines. Virtual machines are basically computer ISO files that boot up into a working computer. These ISO files are of different types. You have it for all operating systems, virtually all operating systems. So all you need is the ISO file, and on one computer you can be able to install a virtual box, and through the virtual box you can able to use this ISO file to be able to spin up multiple machines with different operating systems. And these machines will be able to work normally like regular computers, all on the same network but separated in that the networks of different computers or different virtual machines don't clash or don't interact, except you actually deliberately connect them to be able to talk to each other. So it gives a whole form of security in the internet and in the network, and it gives you the advantage of being able to use multiple computers or multiple virtual computers just running on your one computer, like on your host operating system. Also, now we're talking of mobile networks, which are also advantages of advanced networks. Here we can talk of like for example, we have mobile devices that can connect to the network from anywhere as long as you have a subscription or you have a connection. We can talk about like traffic cameras that monitor activities around the city, even with nobody being there to control them, or no cables connecting to them, just connecting to the internet. We also have some IoT devices or smart sensors in manufacturing or in automobiles. We have smart sensors that work have a kind of network that uh, be able to send information to a central computing device without being connected to the internet or without being plugged up to an internet device like a router or a switch. So